The first example, that a thin rectangular plate having a width of W and a height H is located so that it is normal to the moving stream of the fluid as shown in the figure. Assume that drag force Fd that the fluid exerts on the plate is a function of the width and height, the fluid viscosity, okay, and density rho, and the velocity v, okay, of the fluid approaching the plate. Okay, so in this case we found that there is how many we have for the total variable. So we have 1 2 3 4 5 6, so the total variable is 6, and we use the basic dimension MLT is 3. Okay, and if we list the next we list the basic dimension for 6 variable, okay, for FD H WH mu rho V. Okay, we list in a MLT system. And the next step for the number of pi term, so we have the difference between K and R, so we got 3 pi term, and we choose the repeating the variable W velocity density. Make sure that is independent variable for the repeating variable. And the next step we form 3 pi term. The first pi term is for FD is non-repeating variable times the 3 repeating variable. Okay, the next step we substitute the basic dimension into this term. Okay, for FD is equal to MLT power minus 2, and for W is L power A, for L is velocity is LT minus 1 is power B, and force density is M L minus 3 power C is equal to M power 0, L power 0, and T power 0. Okay, so next step we just check the power of MLT. The for the M power is 1 plus C is equal to 0. So we say that C is equal to minus 1. And for the power of L, 1 plus A plus B subtract 3C is 0. Okay, so we can, if we don't know A and B, so we just leave it. Okay, and for T is power of minus 2 subtract B is equal to 0. So in this case B is equal to 2 minus 2. Okay, so the next step we substitute B and C in the second equation. So we got 1 plus A subtract 2 plus 3 equal to 0. So we can say that A is equal to, conclusion that A minus 2, B is minus 2, and C is minus 1. So we put A, B, C in the both equations. So we found that first pi term is equal to FD divided by W power 2, B power 2, and rho. Okay, that is the first pi term. And the next we work on the second pi term. For H is non-repeating variable, and repeating variable W power A, B power B, and rho power C. Okay, and next substitute the basic unit in. This for H is L, W L power A. Basic for velocity is LT minus 1 power B, and density is ML minus 3 power C is equal to M power 0, L 0, and T 0. Okay, for the power for M, we prove that C is 0. Power for L, 1 plus A plus B subtract 3C 0. Okay, and leave it. And for t is b 0. Okay, so we can substitute a and c in above equation. We got 1 plus a plus 0. Subtract 0 equal to 0. So it means we can prove that a is equal to minus 1, b is 0, and c is 0. So the second pi term is h divided by w. Okay. Okay, we come up, move to the third pi term. And for repeating is the non-repeating is mu. Okay, we substitute the basic unit for mu. ml minus 1 t minus 1. For the power a, and for velocity power b, and density okay for mlt power 0. So we got the power number for m is 1 plus c is 0, and for m is subtract minus 1 a plus b plus and 3 is subtract 1 minus 1 minus b is equal to 0. So we can prove that a is equal to minus 1, b is minus 1, and c is minus 1. So the first pi term is mu divided by the w v rho. Okay. The next step, we just check the dimension. Okay, for the first pi term, so we just check if we prove that using FLD. So we prove that for FD is F, and this is the unit for mu rho for FLD. You can prove that if F is power 0, L is 0 and T is 0, so it's equal to 1. Okay, and for the second pi term, here's the okay, length and length, so this is 1. And the third pi term, V is LT minus 1, and rho is the M L minus 1. Again, so we can prove that the M is power 0, L is 0, and T is 0. Go to 1. Okay, so that is the proof that is all pi term is dimensionless variable. Go back in conclusion. So we can write equation for the relationship between each pi term. The first pi term is a function of another 2 pi term. I can rearrange the equation that is equal to w divided by h. In this term we call the aspect ratio. And the term is rho v. Okay, this term is a real number. Okay.